Hello and welcome to Virtual Summit 2021. This is HealthShare Storage Footprint Reduction. My name is Mark Bolinsky, and I'm the Principal Technology Architect here at InterSystems. I'm responsible for system sizing and planning of our healthcare product lines. I'll be your presenter today, and we'll discuss a few features coming in HealthShare, some actions you can take today, even on older versions, and to lower your storage costs. A quick overview of the agenda for this session. We're going to focus on three specific areas regarding HealthShare storage. One, we're going to identify the elements that are actually consuming storage in your HealthShare deployment. Two, we're going to discuss some compression capabilities that will be available in upcoming HealthShare releases and the importance of regular message purging. And then lower storage costs by leveraging lower cost cloud storage and even on-prem different storage tiers. Let's start by first having a look at what's actually consuming the storage in some HealthShare Edge gateways. The data collected here is from an actual customer, and just using simple tools like %G size or integrity checks will get you this data, and you can put it in a simple spreadsheet. So note, even though I'm showing Edge gateways here, the data size collection process applies to all the HealthShare components, such as the registry, access gateways, document repositories, Health Insight, and so forth. But here we have a deployment with 5 Edge gateways, and you can see in the graph here, there's quite a difference in layout from edge to edge, depending on the usage and the data source behavior. Edge 1 is almost a total of 10 terabytes, but of that 10 terabytes, 8.7 terabytes is audit data only, and 700 gig is actual clinical data. Edge 2 through 4 are similar layouts, with those also having a large audit data footprint, but also notice there's about 1 to 2 plus terabytes of stream data. Streams are used in a variety of areas throughout HealthShare, from just interop messaging workloads to stable, persistent documents in a document repository. Also note that the audit data is not in the HSIHE audit table. That would be centralized, aggregated in a registry or a separate audit repository edge. This audit data here on the Edge gateway is the actual clinical audit data, which contains a copy of the full SDA of the patient at the time of the audit event. We'll be discussing this audit type a little bit more further along. So here we have another set of graphs using the same data, but just pictured differently for more a visual perspective percentage-wise. For Edge 1 on the far left, we can see that the audit and stream data combined accounts for 92% of the total storage, with audit itself being 88% of that. For Edge 2 through 5, we can see a similar pattern of approximately 82 to 87% of total storage for both the audit and streams, but a larger percentage of streams in those other 4 edges. And here we sum the 5 Edge gateways together. As we can see, we have a total of almost 29 terabytes of storage. 86% of that, or almost 25 terabytes of that, is just audit and streams. And as you can see, this is significant and tends to grow exponentially each year, just because of so much more clinical data that's being made available through the EMRs and the other connected data sources. So now that we clearly see the situation, we start by tackling the 3 areas. We introduce stream and journal compression this year, and also a way to move the audit data onto lower cost or tiered storage models. I haven't mentioned journal storage space just yet, and this is another area of HealthShare deployment that can have multiple terabytes of journal files created each day. With this action plan and focus, we have 3 areas in view for now, and certainly there's more to come. Streams, starting with the upcoming HealthShare 21.2 release, stream compression is now going to be introduced. Compression is herited in use, meaning you don't need to change any code within your environment. It's prominent throughout all the interoperability, your business services, the processes, business operations, throughout your whole production. And it'll be visible as the ENS message S global in your database. And this also applies to document repositories, which are storing stable documents. Then we have journals. These are used for recovery, mirroring, pretty much any update from transactions, transformations, simple sets and kills are recorded in the journals. Audit data, as I mentioned earlier, are two types of audit: the aggregated IHE audit data, and then the federated SDA or clinical audit data that's on the edge gateways. And most deployments, these three areas account for well over 50% of the total disk space. And in the examples I've shown earlier, this was in the 80 to 90% range, which is not atypical. It's quite normal. Going to each of these three areas a bit more, let's first start by diving into streams a little bit more. Streams are present in all HealthShare instance types. To address the storage space from streams, we have implemented what we call inline stream compression at the IRS data platform level. And this can be used all throughout HealthShare and all the HealthShare instance types. Testing at scale is shown to be about an 80 to 90% compression rate of all the streams, and CPU impact is minimal at only 3 to 4% increase in our recent benchmark testing, which is pretty much negligible in terms of overhead. A couple things to note: this feature does not compress existing streams by default. Only new streams that are saved in the database. But a simple routine can be written to simply open and then resave the stream as is, and it will gain the compression benefit just on that resaving process. This compression feature can also be turned off and on, and there is no issue reading streams that have been compressed or not. So you can have a situation where you have all your old streams are uncompressed and your new streams are now being compressed, and you haven't gotten around to compressing them yet. So it's a matter of handling it seamlessly. I believe this feature defaults to compression on install, so you will get it right out of the box. And also this feature will be available in the upcoming HealthShare 21.2 release. So the results of stream compression are very encouraging, but for sure. Using the same examples from earlier and assuming an average of 85% compression ratio across all the 5 edge gateways, we reduced from 6 terabytes of stream to now less than 1 terabyte of consumed database space for just streams. We've also tested this in a pure HIE workload in HealthShare with a lot of XDSB documents, and stored document streams also resulted in a net reduction of 85% compression. Again, these results are very exciting, and this is just the first step. Next, moving on to journal compression. Deployments with high transaction rates and/or a lot of transformations can generate a lot of terabytes of journals per day. This ties up a lot of storage space and expensive storage at that, since the active open journal file needs performance and the low latency that you get for all the writes. With journal compression enabled in testing in our benchmarks, we're showing again around an 80 to 85% compression as well, and it's only compressed once the journal file is switched and closed. Now, this feature is available in IRS data platforms and IRS for Health for 21.2, but unfortunately, it probably won't make it into the upcoming HealthShare 21.2 release. It will be picked up in the first of 2022 with the 22.1 release. To illustrate this a bit more, here we have the HealthShare instance running and writing to the active journal file. As I mentioned earlier, one key difference with the journal compression versus stream compression is that journal compression is offboard from the active journal file and is only compressed once closed and switched. This was deliberate so the performance of the journal writes are not slowed down from the compression activity itself. The active journal file is not compressed, so you'll have anywhere from 1 to 4 gigabyte of journal file that will not be compressed, depending on what you have your configured max journal file size set to. 1 to 4 gigabyte compared to multi-terabytes, it's just a drop in the bucket. But as soon as that journal file switches and closes, that journal file will be compressed. This is where the storage savings comes into play, because sites will have hundreds or even thousands of journal files per day, per instance, accounting for these multiple terabytes depending on activity. So using our examples from earlier, the same edge gateways, they have 4 terabytes, 2 terabytes, 1.5 and 1 terabyte of journal space on each one respectively. With journal compression, we're expecting a significant reduction in total journal disk space from a total of 10.5-ish allocated journal disk space to now only needing about 1.5 terabytes of journal disk space. And our third area of focus, audit data. As I mentioned earlier, audit data is in numerous locations, and there's 2 different types. There is the central aggregated ATNA audit repository in the registry or in a dedicated audit edge. And then the clinical data on the edge gateways with a copy of the patient record or the SDA saved at the time of the audit event. An audit record itself is never updated, and the table is only ever appended or inserted to the end of the table. And along with that, requirements for audit retention varies from customer to customer, region to region, based on regulatory or government requirements. As we found earlier in the edge gateways, the HS Audit Global accounts for a significant amount of space. However, I want to note that when using ODS, patient retrievals from the access gateways in the clinical viewer to the ODS or the operational data store will not save the entire SDA in the audit, but it only stores pointers to the SDA containers of the items that were accessed. So this translates to just a few kilobytes of audit data instead of having multi-megabytes of audit data per audit event. So given that the audit data hangs around forever and never really goes anywhere or purged, although there is a feature we're working on for next year, hopefully to have a formal archive and purge mechanism, but we need right now to look at ways to lower the cost of persisting that audit data. In our previous example, we had almost 19 terabytes of audit data in the edge. And again, this is data that is rarely, if ever, accessed, but usually needs to be retained because, again, of regulatory and compliance needs. For example, using AWS, Elastic Block Store, or EBS with their GP2 volumes, to support that 19 terabyte is approximately almost $1,900 a month at the US list price of about 10 cents per gigabyte per month. Then if you add in database mirroring to that, it's over $3,700 on high-priced EBS for data that's rarely, if never, accessed. So to lower the cost of that, we look into using subscript level or SLM global mappings to move most of that data to a separate iris.dat file for within a given edge gateway namespace. It'll go to an alternative EBS type such as an ST1 or an SC1, which have a much lower price point of 4.5 cents per gig per month and as low as even 1.5 cents per gig per month, respectively. To accomplish this, you can simply use existing data move or gblock copy utilities that are available in Iris or Cache. And it can be, again, accomplished with either current, upcoming, and even older versions of HealthShare that are still Cache-based. We may look to automate this feature to make this more of an automatic push to older .dat files to a secondary location or path, which is on lower cost storage. I did provide a link here to the details on how to use subscript level global mappings and data move. Using the edge gateways examples again from before, so we can reduce that $1,800 a month to as little as only $848 for an ST1, or even as low as $282 when using SC1. And if you're using database mirroring, you would, of course, you would double that because there'd be 2 copies. But now, just a reminder that both ST1 and SC1 EBS volume types will have a lower performance in the form of higher latency and lower bandwidth compared to the higher cost, higher performant GP2, GP3, IO1, IO2 EBS volume types. And the same would apply for Azure and Google as well. There are multiple storage tiers across all the big 3 cloud vendors. Also, the same steps can be used on-prem, again, using lower cost storage arrays or different disk pools that you want to allocate for it. So if you want to have all your primary production data that needs high performance sitting on an all-flash array, you can have secondary storage, whether it's even a NAS appliance through NFS or CIFS that has a network-mounted volume. on a lower tier storage. So that way the database is still accessible, but it's just going to come with a slower performance. And so it'll be a matter of just setting the expectations and setting an understanding of how that performance is going to be. So the key takeaways from this session are stream compression, journal compression, and leveraging lower cost storage tiers for your audit data. And this makes up a significant reduction in storage footprint and the storage costs. For those customers that haven't yet implemented or are using the HealthShare Operational Data Store, aka ODS, there is a significant reduction in audit storage because it doesn't save a full copy of the entire patient's SDA on a retrieval event. And also a bit of a commercial that ODS is also faster in access to that data because the SDA is already pre-aggregated and cached within ODS. Just to give you some insights into additional future plans, we are looking into inline database compression. It was available in IRIS 21.2 as an experimental change, but we did run into some issues in testing, so we haven't implemented it for HealthShare just yet, but hopefully in 2022, this will be available. The initial testing is very promising in terms of how much it's returning, and we're seeing about an 80 to 90% inline compression and would be a great candidate for all those audit databases as well. Automatic journal archiving to push to lower cost storage. This will be in addition to the journal compression and to be able to move journal files automatically to secondary location and even cloud-based object storage such as S3 or Azure Blob Storage. And then we have the HealthShare System Indexing Service, or the SIS, as a new upcoming component of HealthShare to aid in performance scaling and also benefit from reduced audit storage footprints, very similar to what ODS does today. There is a session, I think, dedicated specifically for the System Indexing Service that's coming in 21.2. And last but certainly not least, a potential audit archive purge mechanism to offload audit data from the operational database, the iris.dat files. So that way, instead of just pushing data to secondary slower storage, there might be an option to actually remove it from that completely, or just more automating the process to push it to slower storage or cheaper storage, which will is going to be more of a manual process, at least for the start. So please stay connected with this. My contact information is listed here, and also follow me on my LinkedIn page for some interesting posts, articles, and events that are coming up. And with that, I thank you very much.